My name is Ramakrishna. I'm faculty in mathematics +1 and +2. Today we will discuss about conic section. Now here, this board can be treated as a plane. This board can be treated as a plane. In this plane, you take any fixed point. You take any fixed point that is denoted by S. Now in the same plane, you take any fixed line that is denoted by small l. This is nothing but fixed point. This is nothing but fixed line. Now you take another point in the same plane that is denoted by some p. Then what is the definition of the conic means? The locus of the point p. The locus of the point p is such that its distances from the fixed point and the fixed line which are in constant ratio, that is denoted by small e. Then the locus of this point is called conic. And indirectly, now let S be a fixed point and L be a fixed line in a plane, and you take another point in the same plane that is denoted by P. Then the locus of this point P is such that its distances from the fixed point and the fixed line which are in the constant ratio, E, then that the locus of that point P is called conic. Indirectly, now the distance from these 2 points is nothing but SP, and the distance from this point, this line, is nothing but PM, which are in constant ratio. Ratio is nothing but division. Now SP by PM is equal to E. Then the locus of this point is called conic. Now here in this definition, this fixed point is called focus of the conic, and the fixed line is called directrix. This fixed line is called directrix of the conic. And this is any point lies on the locus, and E is called eccentricity. E is called eccentricity of the conic. Now here we draw a line which is passing through S. Now we draw a line which is passing through S, and that line is always perpendicular to directrix. Then that line is said to be principal axis of the conic. And this point of intersection of the principal axis and directrix is denoted by some z. Now here in this definition of the conic, now the line which is passing through focus and perpendicular to directrix is called axis of the conic, and that is always perpendicular to directrix. Now here in this definition, E is called eccentricity. Here in this definition, if eccentricity value is always 1, then that conic is called is called parabola. Next, if eccentricity value lies in between 0 and 1, then that conic is called an ellipse. And if eccentricity is more than 1, then that conic is called hyperbola. And if eccentricity value is equal to 0, then that conic is called a circle. Next, if eccentricity value root 2, then that conic is called a rectangular hyperbola. And if eccentricity value approaches to infinity, then that conic is called a pair of straight lines. This is about the definition of the conic. Now we learn about what is the equation of the conic. Here in this definition, now SE is nothing but fixed point. Indirectly that is called focus. And what about the coordinates of S means indirectly ordered pair of any two real numbers which are denoted by S of alpha comma beta. Now here focus coordinates are nothing but alpha comma beta, and this is nothing but fixed line. This line can be denoted by like this: Lx plus My plus N is equal to 0. And indirectly this is nothing but general form of a straight line, means it is a linear equation in x comma y, and L square plus M square is always not equal to 0. And this is any point lies on the locus, means indirectly here locus of this point is nothing but conic. Now let P of x1 comma y1 be any point lies on the locus. Now with the help of this condition, conic condition, what is the conic condition here? SP by PM is equal to E. SP is equal to, we can write E into PM. Now what about SP? SP means the distance between these 2 points, that is already we know the distance between 2 points, that is always equals to under root of x2 minus x1 whole square. That means we can write x1 minus alpha whole square plus y2 minus y1 whole square, means we can write y1 minus beta whole square is equal to eccentricity E, you write as it is. What about PM? PM means the perpendicular distance from P x1 y1 to this directrix. That means Lx plus my plus n is equal to 0. Already we know the perpendicular distance from P x1 by 1 to the given line Ax plus By plus C is equal to 0 is nothing but a modulus of Ax1 plus By1 plus C by under root of A square plus B square. We are applying same formula for this, that is always equals to Lx1 plus My1 plus n divided by under root of L square plus M square. And here indirectly this is nothing but the perpendicular distance from P x1 y1 to this fixed line Lx plus My plus n is equal to 0. Now that means we can write now squaring on both sides. Now squaring on both sides and cross multiplying, that is always equals to L square plus M square. L square plus M square. Now which can be taken to left hand side. Now into x1 minus alpha whole square plus y1 minus beta whole square is always equal to E square into Lx1 plus My1 plus n whole square. Now we are simplifying this total equation, then it can be converted into, now we are simplifying this total equation which can be converted into this form: ax square plus 2hxy plus by square plus 2zx plus 2fy plus c is equal to 0. Now we are simplifying this total equation which can be converted into this form: ax square plus 2hxy plus by square plus 2zx plus 2fy plus c is equal to 0. And indirectly this equation is called second degree equation in x comma y. Second degree equation in x comma y, and whose discriminant already we learn in straight lines, pair of straight lines, whose discriminant is always equal to delta is always equal to abc plus 2fgh minus af square minus bg square minus ch square. This is nothing but discriminant of this second degree equation in x comma y. Now indirectly this second degree equation in x comma y now satisfies the following conditions. Now indirectly that equation denotes different types of conics, means for first type conic. Now first one is nothing but parabola. Now this equation represents a parabola. This equation represents a parabola if it satisfies this condition. If it satisfies this condition, if delta is always not equal to 0, if delta is always not equal to 0 and it satisfies this condition, h square is equal to ab. For suppose this equation satisfies this condition, then that equation denotes the equation of the parabola. Next, this equation denotes an ellipse if it satisfying this condition, if delta is not equal to 0. If delta is not equal to 0 and h square is less than ab. For suppose this equation denotes a hyperbola if it satisfying this condition, if delta is not equal to 0 and h square is more than ab. For suppose this equation represents a circle. This equation represents a circle if it satisfies this condition. Now that is always equal to, if delta is not equal to 0 and a is equal to b and h is always equal to 0 and g square plus f square minus ac is more than or equal to 0. Next, for suppose this equation represents a rectangular hyperbola. A rectangular hyperbola if it satisfying this condition, if delta is not equal to 0, delta is not equal to 0 and h square is more than ab and a plus b is equal to 0. Next, for suppose this equation represents a pair of straight lines. This equation represents a pair of straight lines if it satisfying this condition, if delta is always equal to 0 and f square is more than or equal to bc and g square is more than or equal to ac and h square is more than or equal to ab. That means the equation of the conic is always second degree equation x comma y, and which is in the form ax square plus 2hxy plus by square plus 2zx plus 2fy plus c is equal to 0. That equation represents a parabola if it satisfies this condition, delta not equal to 0 and h square is equal to ab. This equation represents an ellipse if it satisfying this condition, delta not equal to 0 and h square is less than ab. Now if this equation satisfies this condition, delta is not equal to 0, h square is more than or equal to more than ab, then that equation is nothing but equation of the hyperbola. This equation represents a circle if it is satisfying this condition delta not equal to 0 and A is equal to B, H is equal to 0 and G square plus F square minus AC is more than or equal to 0. Now this equation represents a rectangular hyperbola if it is satisfying this condition delta not equal to 0 and H square is more than AB and A plus B is equal to 0. And this equation represents a pair of straight line if it is satisfying this condition delta equal to 0, F square is more than or equal to BC and G square is more than or equal to AC and H square is more than or equal to AB. This is nothing but the definition of the conic and the equation of the conic, and that equation satisfies different value. Now here different eccentricity values, and that equation represents a different type of conics which are based on these conditions.